Chapter 11. Chapter 11. So I'm a big fan of test, and this is the chapter about writing test. Let's go. Writing automated tests. In his 1972 essay, The Humble Programmer, Edgar W. Dijkstra said that program testing can be a very efficient way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. That doesn't mean we shouldn't try to test as much as we can. Okay, yeah, Dijkstra. Classic. Correctness in our programs is the extent to which our code does what we intended to do. Rust is designed with a high degree of concern about the correctness of programs, but correctness is complex and not easy to prove. Rust's type system shoulders a huge part of this burden, but the type system cannot catch every kind of incorrectness. As such, Rust includes support for writing automated software tests within the language. Testing. Oh, this page isn't long. Cool. As an example, say we write a function called add2 that adds 2 to whatever number is passed to it. This function signature accepts an integer as a parameter and returns an integer as a result. When we implement and compile that function, Rust does all the type checking and borrow checking that you've learned so far to ensure that, for instance, we are not passing a string value or an invalid reference to this function. But Rust can't check that this function will do precisely what we intend, which is to return a parameter plus 2 rather than, say, a parameter plus 10 or a parameter minus 50. That's where tests come in. So yeah, what they're saying there is pretty straightforward. So the borrow checker can check that our code is more or less safe to run, and that our code adheres to the Rust syntax. But outside of that, we got to write tests to check for everything else. We can write tests that assert, for example, that when we pass 3 to the add2 function, the return value is 5. We could run these tests whenever we make changes to our code to make sure any existing correct behavior has not changed. Testing is a complex skill. Although we can't cover every detail about how to write good tests in one chapter, we'll discuss the mechanics of Rust's testing facilities. We'll talk about the annotations and macros available to you when writing your tests, the default behavior and option provided for running your tests, and how to organize tests into unit tests and integration tests. This is going to be good. This is needed. This is needed. How to write tests. Tests are Rust functions that verify the non-test code is functioning in the expected manner. The bodies of test functions typically perform these 3 actions. 1. Set up any needed data or state. 2. Run the code you want to test. 3. Assert the results or what you expect. Let's look at the features Rust provides specifically for writing tests that take these actions, which include the test attribute, a few macros, and the should panic attribute. The anatomy of a test function. At its simplest, a test in Rust is a function that's annotated with the test attribute. Attributes are metadata about pieces of Rust code. One example is the derive attribute we use with structs in chapter 5. To change a function into a test function, add #test on the line before function. When you run your test with the cargo test command, Rust built a test runner binary that runs the functions annotated with the test attribute and reports on whether each test function passes or fails. So what they're saying here is that in order to create a test function, they're just regular Rust functions. However, these Rust functions are marked with this attribute called test. And then when we run the cargo test command, it just looks for everything that has this attribute on it and it runs it, seemingly. When we make a new library project with Cargo, a test module with a test function in it is automatically generated for us. This module helps you start writing your tests so you don't have to look up the exact structure and syntax of test functions every time you start a new project. You can add as many additional test functions and as many test modules as you want. We'll explore some aspects of how tests work by experimenting with the template tests generated for us without actually testing any code. Then we'll write some real-world tests that call some code that we've written and assert that its behavior is correct. Let's create a new library project called adder. All right, looks like I have to open my terminal and run this command. Let me just copy that. And I already have a directory here that I would like to do it in. Paste. And cd, just make sure it exists. It does. Let's see if I can open that with PyCharm. Oh, okay. So yeah, I've opened adder, right? And adder has a source file. And normally we have a main, but this is a library, I believe. So they gave us a lib.rs file, and that has the test in it. Okay. Okay. Let's see what else they want us to do. The content of the source.lib.rs file in your adder library should look like listing below. And just taking a quick look back and forth, that is it. And this is the thing they have over test. I'm not sure what this CFG is needed for, but hopefully they'll explain it. For now, let's ignore the top 2 lines and focus on the function to see how it works. Ignoring the top 2 lines, that's this and this. Note that the hashtag square brackets test annotation before the function line. This attribute indicates that this is a test function, so the test runner knows to treat this function as a test. We could also have non-test functions in the test module to help set up common scenarios or perform common operations. So we need to indicate which functions are tests by using the test attribute. Scrolling down. The function body uses an assert equals macro to assert that 2 plus 2 equals 4. Let's see that. That is here. Okay. This is the macro, assert. 2 plus 2 equals 4. Yep. This assertion serves as an example of the format for a typical test. Let's run it and see that this test passes. And I can just run cargo test. Let me make that a little bit wider. Cargo test. Version 0.1. And it passed. So what else does it have here? Running one test. Test, it works. That's the function name, it works. Test, I don't know. Oh, test. This is the module for test. I see it. That makes sense. Dot, dot, dot. Okay. Results. Doc test. You can do documentation test. Okay, that's good to know. Ran 0 of those. And we passed. Understood. So yeah, I just read out that stuff, but from my output. Moving onward. Cargo compiled and ran the test. After the compiling, finished, and running lines is the line running one test. The next line shows the name of the generated test function called it works and the result of running that test. Okay. The overall summary of running the test appears next. The text test result okay means that all the tests passed, and the portion that reads 1 passed 0 failed totals the number of tests that passed or failed. Pretty straightforward. Because we don't have any tests we've marked as ignored, the summary shows 0 ignored. We also haven't filtered the test being run, so the end of the summary shows 0 filtered out. We'll talk about ignoring and filtering out tests in the next section, controlling how tests are run. Okay? The 0 measure statistic is for benchmark tests that measure performance. Benchmark tests are, as of this writing, only available in nightly Rust. Ooh, that sucks. You can only do benchmarking in nightly Rust right now. Hopefully it'll get moved over soon. See the documentation about benchmark tests to learn more. Understood. The next part of the test output, which starts with .test_attr, is for the result of any documentation test. We don't have any documentation tests yet, but Rust can compile any code examples that appear in your API documentation. That sounds amazing. This feature helps us keep our docs and our code in sync. We'll discuss how to write documentation tests in the documentation comments as test section of chapter 14. For now, we'll ignore the .test output. That does not sound amazing. So what they're saying here is that we have the ability to write our documentation in here and have it run with our tests so that our tests and our documentation are always in sync. That's an issue in a lot of other languages and a lot of other places. But what is not cool is they're saying that we won't learn how to do that until chapter 14. Unless we, I guess, click through and just jump to that. But you have options. Let's change the name of our test to see how that changes the test output. Change the it works function to a different name, such as exploration, like so. Sure, why not? I mean, exploration. Run. Exploration. Then run cargo test again, which I just did. The output now shows exploration instead of it works, which makes sense because the function that was ran is called exploration. Test for the module, ... exploration for the function. Skipping that because that's all the same. Let's add another function, but this time we'll make a test that fails. Tests fail when something in the test function panics. Each test is run in a new thread. And when the main thread sees that a test thread has died, the test is marked as failed. We talked about the simplest way to cause a panic in chapter 9, which is to call the panic macro. Enter a new test, another, so your source lib.rs file looks like the following. And they added another test. So let me just put spaces here because I guess it doesn't need a space. But down here, we're adding another test. So we start off with the attribute, which is called test, right? Then we have our function name, another, like they stated. And then here we're just going to make a panic, or write a panic. Make this test fail. So this should show us something, but before we get to that, I want to touch on something they said here that I find interesting. This line right here. Each test is run in a new thread. So I find this interesting because seemingly to me this means that our tests have the possibility of running in parallel or asynchronously, as in instead of one test runs, the next test runs, the next test runs in sequence order, or in a sequence, we can have test run, and as soon as they finish, they report back to the main thread. That means our tests could potentially run much faster than they would in some other languages. So yeah, moving on, let's run this down here. So looking at output, we have the cargo test running 2 tests. This one is noted as failure. And then you have the listing of your failures. Another test, and here's the standard output from that failure. And here's the panic that we called or raised. And the test results failed, and it has our 1 pass, 1 failed. Everything else same as before. So run the test again using cargo test. The output should look like listing below, which shows that our exploration test passed and another failed. And I went through this, we already walked through it, so let's continue onward. Instead of OK, the line test, another shows failed. 2 new sections appear between the individual results and the summary. The first section displays the detailed reason for each test failure. In this case, another failed because it panicked at make this test fail, which happened on line 10, in the source lib.rs file. The next section lists just the names of all of the failing tests, which is useful when there are a lot of tests and lots of detailed failing test output. We can use the name of the failing test to run just that test to more easily debug it. We'll talk more about ways to run tests and controlling how tests are run. Oh, they did it again. They told us about a feature and then they won't describe it until later on. Basically what they're saying here is, one, we have different output. We have the which test failed, their output, and then after that we have a section that just lists out all of the failed tests, right? And then they got to the interesting part, which was you can run a single test. You can filter your test such that you only run that one failed test, so you can debug it. And then they told us we won't get to do that until the next section, which isn't too far away, but still kind of annoying. The summary line displays at the end, overall, our test result is failed. We had one test pass and one test fail. Now that you've seen what the test results look like in different scenarios, let's look at some macros other than panic that are useful in test. Moving onward, we have an assert macro, okay? Checking results with the assert macro. The assert macro provided by the standard library is useful when you want to ensure that some condition in a test evaluates to true. We give the assert macro an argument that evaluates to a Boolean. If the value is true, assert does nothing and the test passes. If the value is false, the assert macro calls the panic macro, which causes the test to fail. Using the assert macro helps us check that our code is functioning in the way we intended. So we have an assert macro that evaluates to a Boolean, or checks against a Boolean, and then raises a panic. Understood? In chapter 5, listing 5.15, we used a rectangle struct and a canhold method, which are repeated here in listing 11-5. Let's put this code in the source lib.rs file and write some tests for it using the assert macro. Alright, let's write this information in. Yeah, I'll type it by hand. I could copy and paste it, but meh. Alright, so we have derive, which allows us to print out debug information for our struct. Debug, right? We write our struct, call it rectangle. We're going to do the width U32, height U32, and now we're going to write our method that we're going to test against, or the method that we're going to, and now we're going to write the method that we test. So we create an implementation block to create the method, and its function canhold, which starts off with a reference to self. We have other, which is going to be a reference to another rectangle, and this is going to return a Boolean. And then now we're just checking against the dimensions. So making sure the width of this instance is going to be greater than the width of the rectangle that's passed in. So other dot width. We do the same thing for height. Dot height is greater than other dot height. And that should be fine. So now that we have that written, we can scroll down here. The canhold method returns a Boolean, which means it's a perfect use case for the assert macro. Listing 11-6, we write a test that exercises the canhold method by creating a rectangle instance with the width of 8 and the height of 7, and asserting that it can hold another rectangle instance that has a width of 5 and a height of 1. And now we're going to write out that test. I'm not exactly sure if they deleted this block or wrote another one, but in theory we should be able to write another one. This should work just fine, but let's see what happens. Test mod test super star, and I typed it wrong. I have to use. So yeah, this superline, I believe this superline is what allows us to use this rectangle in this module, because modules are different scopes in themselves. So we're inheriting everything from super, which is, I believe, one module up, which is this stuff. Sorry, not inheriting, importing. Importing everything, and that's one module up. And now we write the test. Hashtag test. Function larger can hold smaller. Let larger equal rectangle. And we give it a width of, they said 8, and a height of 7. You are almost done. Typos. And we're gonna say let this be smaller. Rectangle. Width of 5 they have there. Height of 1. And now they have an assert. So one thing I noticed when typing assert is that we have assert underscore equals, assert not equals, NE. We have some debug asserts, which probably compares the output of a struct in debug mode to other structs in debug mode. Maybe, maybe not. But what I'm not seeing is assert. However, when we type it, it does change color, so it's here. Larger can hold smaller. Hopefully this runs, because I'm noticing that our struct name isn't being passed here. But let's see what happens. And we have an error. And the error might be because we have two different modules with the same name. And we have another error here. Oh, that's a warning. Canhold is never used. So this maybe can exist at the same time. Maybe you cannot have two modules with the same name. That would make sense. So this time we ran it. Once we deleted the second module, the duplicate module, we still get the same warning that this canhold is not being ran. It's only being ran in test, so technically speaking, outside of test, it's not being run. They are correct. And then our test says that we have run the larger can hold smaller. It was okay. One test passed, and everything else is same as it was before. Null values. Okay, let's see what they have here. Note that we've added a new line inside the test module, use super : star. The test module is a regular module that follows the usual visibility rules we've covered in chapter 7 in the modules as the privacy boundary section. Because the test module is an inner module, inner being it's a module within a module, you have the main module, which is 1, and this is the module within that module. We need to bring the code under test in the outer module into the scope of the inner module. Really wordy, but more or less we need to bring in this code and make that code usable in this module. And in order to do that, we use this line. Where is it? We use a glob here, so anything we define in the outer module is available to this test module. The glob being the star. Star meaning all things in the super module. Super being one module up, which is this stuff. I guess anything outside in this area. We named our test. Larger can hold smaller. And we've created the two rectangle instances that we need. Then we called the assert macro and passed it the result of calling larger can hold smaller. This expression is supposed to return true. So our test should pass. Let's find out. We did that. It does pass. Let's add another test. This time asserting that a smaller rectangle cannot hold a larger rectangle. And this should be another test case. So test function smaller cannot hold larger. Okay. And then we have the same rectangles. They're probably going to refactor this later so you don't have to copy and paste this or write the same stuff twice, but let's do it that way for now. And we're doing assert. Oh, I see what they did there. So they have an assert, right? But in here we have a exclamation point, which is the opposite of whatever was returned. So assert checks that something is true. If something is true, then it keeps going, and if it's false, it panics. Smaller dot canhold reference larger is going to return false. However, in order for the test to pass, because we want it to pass, we don't assert something is false, we assert something is true. So the opposite of this result, which is false, is going to be true, and thus we negate it here. And here we have two tests passed, running two tests, smaller cannot hold larger. Scroll down here. Because the correct result of canhold function in this case is false, we need to negate that result before we pass it to the assert macro. Because the correct result of the canhold function in this case is false, we need to negate that result before we pass it to the assert macro. As a result, our test will pass if canhold returns false, which I've shown. Two tests that pass. Now let's see what happens to our test results when we try to introduce a bug in our code. Let's change the implementation of the canhold method by replacing the greater than sign with a less than sign when it compares the widths. Alright, so we're going to the canhold, and now we're going to change it so that it is going to be incorrect. We're introducing a bug. The bug is changing these signs. The width, so we have like self.width has to be greater than other.width. Make it less than. Same thing for the height. And now we're going to run our test, which we're in a passing state, and now should be in a failing state. And the reason our test failed is because we introduced a bug to our source code. And see what they have here. That was the warning. Running two tests. Here's name. They both failed. Failures. Here's the output of them. And then here's the list of failures. And then the final result. Failed. Two failed. Everything else, no. Running the test now produces the following. Huh? Oh, they only changed the sign of one. I changed the sign of both. Really? So if we don't change this one test passes? That's kind of wonky. Yeah, one test passes. And which one passed? The smaller cannot hold larger. Understood. Our test caught the bug. Because larger.width is 8 and smaller.width is 5, the comparison of the widths in canhold now returns false. 8 is not less than 5. So larger can hold smaller. The first test right here. With 8, 5, larger. 8 is not less than 5. So this section returns false. And thus this entire thing returns false. And the test fails. Makes sense. Moving onward.